In this video, we will discuss a relevant example of plotting, since we will be plotting experimental data. A usual platform to store data is Excel. However, we all had the problem of Excel graphs that never look the way you want. Therefore, let's learn how to plot experimental data in MATLAB, so in the future you will be able to plot the most beautiful graphs. As you have learned before, MATLAB requires two inputs, either numbers, vectors, or matrices of the same size in order to plot data. However, a lot of lab equipment stores data in tables or other unusual formats. In this exercise, we have an Excel file that is a perfect example of this. It's called output data. Let's load it into MATLAB and see what we can do. So let's open a new MATLAB file. And now to load the data, we can use the command xlsread, and then between parentheses and between apostrophes, type the name of the file. And here it's extremely important that the file is saved in the same folder as your MATLAB file, as your working folder. So then type the exact name, also case sensitive, between the parentheses. And then when we run it, we see that we have indeed loaded the data of the Excel file. Now let's investigate the size of the table we got in Excel. And we can also store this size by using the following line. Well, how does this work? When you have a matrix, in this case a matrix of data, this matrix will have an m amount of rows and an n amount of columns. And this is exactly what the size command returns, the amount of rows and the amount of columns. When you want to store these two as separate variables, you can define a vector of these two variables, in this case rows and cols. This way, the rows variable will get a number of the amount of rows and the cols the amount of columns. When we run this script, we see that the data we got has 5 rows of 20 columns. So there's 20 columns with 5 data points each. In the MATLAB script, we have seen that the data is stored in small blocks of 5 data points each, 20 blocks total, and we have to rearrange them in such a way that we can plot them. Well, what is the easiest way to do this? A nice approach to make a row vector out of it is to take the first column and paste the second column under it. Now we already have a vector of 10 by 1. Then we can take this column and paste the third column under it, so it becomes a vector of 15 by 1. We can repeat this until we placed all columns under each other, resulting in a long row vector. This row vector has a length of 100 by 1. So, what do we use when we want to kind of walk through the data? Exactly, a loop. Do we know how many steps we need to take? Yes, because we know the amount of data we want to process. Therefore, we use a for loop. Then, there's one last issue to solve, since how do you paste vectors under each other? Let's first define an empty vector. In this vector, we can place the first column, column 1. That's easy, right? Then we can simply add the next column by making a new vector in which we put the first vector and paste the second column in there. We can repeat this with the third vector and so on. As you notice, the column numbers correspond with I, so we can use this index to refer to the right column. Since we are not interested in the steps between, we can just overwrite the vector each step. This means we don't have to use indices for the data, we can just override it. Let's try this in MATLAB. We were going to use a for loop, and we already saw that we were going to do this for the amount of columns. So for I is 1 until we went through all columns. Then let's go to the core of the function. Let's call the vector we are going to build differently than the first vector, because else we will override our input data and that's not useful. So let's call it data plot, and this vector is going to exist out of the previous data plot, which is in the first round an empty vector and then exists out of column 1, then out of column 1 and 2, etc., etc. And then the column from which we want to take from the data. So in the first round, this will be the first column, then the second column, etc. In order to do this right, it's important to understand what we've typed here. So first of all, the data set we're taking out of the data is a column vector. It's a column of 5 by 1. And this column we want to paste below another column. That is why we use the semicolon. This means that two inputs in a vector are pasted below each other. If you don't use the semicolon, this script will paste all the data next to each other, and you basically end up with the data you already started with. Then also pay attention to the way we say to MATLAB that we only want one column. We do this with data and then colon and then an I. Colon basically means all. So when indexing, you always have the first value is the rows and the second value is the amount of columns. So by saying data all rows, but only column I, you refer to only one column. So you take all the values in the vertical aspect, which you do with the colon, but only the values of one column in the horizontal aspect. And this way you target only one column. So now we have that, we can run the script in debugger mode, so we can see each intermediate step of MATLAB and see if it works. Also, don't forget to define the initial empty vector data plot, because else MATLAB will give an error. So when we run this, we see the output vector data plot growing and growing and growing. So indeed, we managed to paste the columns of this data underneath each other. So now we've done that, let's check if we can plot it. Of course, we need something to plot against, time in this case. So let's construct a vector of 1 until the length of the data we are going to plot against, and make a vector out of this, and then also inverse this vector. Why do we do this? Well, the data we just constructed is a column vector of 100 by 1. However, the vector we just defined, MATLAB automatically makes a row vector out of it of 1 by 100. And as you know, a row vector and a column vector cannot be plotted against each other. By adding the little apostrophe, you transpose the vector, which means that it becomes a 100 by 1 vector. And this is a column vector, so this way we can plot the values against each other. Now we have all the input data, we can plot the data against each other. And indeed, results in a plot. However, this is not how we want the plot to be. They're still missing a lot, like axis labels, titles, and also the formatting isn't right. So let's think a bit about how we want to plot our data. Well, first of all, a little tip. Under help, then MATLAB, then graphics, and then under create and customize your graph, you can find all about how to plot a graph and how to customize it the way you want your graph to be. I'm not going to show all of them in this video, so let's just use what I know by heart. First of all, let's think about the line style. There's a certain convention that when you have measurement data, you always plot these in dots or bullets or whatever. When you want to model a trend line through it or use a line as a kind of approximation, you are welcome to do that. But if you have measurement data, always use dots. In this exercise, it's quite clear to also add this line to the measurement data. So let's do that. So we can specify the line style by between apostrophes, type what kind of bullet you want, and then also the color. So for example, we now use a round bullet with a line through it in blue. The B stands for blue. So let's also immediately add the title to the plot and also add X and Y labels. Now, when we plot it, it already looks much better. We can see the separate data points, but also a line that approximates the trend of the data. And we can actually read from the axis what we are plotting and what experiment this is. So it's already much better. Now we want to add the line y is 0.5 to see where the time of interest is. In order to do this, we need to create a vector that is just as long as the time vector. The vector should have value 0.5 everywhere, so it becomes a straight line. We can do this by making a vector of ones of the right length and then multiplying this vector by 0.5. Now we have a long vector of 0.5. So let's plot this line as well. We want the line to be dashed and red. That seems nice for a threshold value. We can specify this by typing 2 dashes, which results in a dashed line, and an R for a red line. So now we plot, and oops, we've overridden the previous figure. That's not useful since we want to compare them. We can prevent this by typing the command hold on with a space between. This will prevent MATLAB from closing the first figure, so both figures are plotted in the same screen, as you can see here. And now we have both lines in the same plot, and we see that the threshold value is somewhere around 62. Now you've managed to solve the exercise. Try to play around a bit with the properties of your graph to learn how to make beautiful plots. For example, let's make the width of the line a bit thicker. We can do this by specifying the string line width right in the plot command, and then give a size. And you see the line is much thicker, not necessarily prettier, but it's thicker. You can also change the size of the fonts, for example, the title, by specifying the string font size and then a size. And you see the title has grown. Another option is, for example, to use a grid in your plot, which is quite useful, especially in this case. You can do this by typing grid and then a space and then on and then running again. And you see there's a grid. So there's all types of options. Everything's there to make the most beautiful plot you've ever seen. Look into the MATLAB help pages to find out more about the options MATLAB has to make nice plots. And, well, try to play around a little.